Notes 2A.4H. Solving quadratic inequalities. Your Algebra 2 standard is 4H. Solve quadratic inequalities. Our first example, we have y is greater than or equal to x plus 3 squared minus 4. The first thing you want to do is just graph it like it's a normal equation. So we know that our vertex is -3, -4. Change keep. So -3 and then -4. So let's plot that point. And then it's opening upwards. So it'll be going up this way. And it's less than or equal to, so it's going to be a solid line, a solid curve here. And then if it had no line, it would be dashed. All right, now from here, we're going to use our test point 0, 0. All right, to do that, we're going to plug in 0 into the inequality and see if it's true or false. So is 0 greater than or equal to 3 squared minus 4? Is 0 greater than or equal to 9 minus 4? Is 0 greater than or equal to 5? That's false. So that means we're not going to shade 0, 0. We're instead going to shade everything that's not in that area. Okay, let's do the next one. Y is less than or equal to x plus 2 squared plus 1. So we're going to find our vertex first. And it's -2, 1. So we plot that point. And then it's opening upwards, so it's going to be facing up. And let's plot a few points. The way I'm finding these points is that for a standard quadratic, this is 0, this is 1, this is 4 from right here. These are in increments of 1/2, so you would just double each of those. So this would be 2, the next one would be 8. 1, 2, 3, 4, 5, 6, 7, 8. And go right here. And then it's a mirror image, so you do the same thing on the other side. And then it's a solid line, a solid curve, because the inequality has a equal sign underneath. Okay, now let's test the point 0, 0. Is 0 less than or equal to 0 plus 2 squared plus 1? Is 0 less than or equal to 2 squared plus 1? Yes, that's true. So you're going to shade the side with 0, 0. And there's 0, 0 for the reference point. So you're going to shade everything that is on the side with 0, 0. Let's do the third example. Y is greater than -x minus 3 squared minus 2. your vertex is 3, comma, negative 2. It's opening down because we have that negative sign. So let's find that vertex. We have 3, negative 2. And it is an inequality without a line under it. So we're going to have holes and dashes instead of points and curves. So let's go ahead and plot some points. So 2, 3, 4, 5, 6, 7, 8. And then we're going to draw some dashed lines to make the dashed curve. Okay, let's use the reference point 0, comma 0 to test it out. Is 0 greater than negative 0 minus 3 squared minus 2? Is 0 greater than negative 3 squared minus 2? Is 0 greater than negative 9 minus 2? Yes, that's true. So we'll shade that side. So we'll shade everything on this side that contains 0, comma 0. This side of the curve. So we're basically shading above the curve, the quadratic curve here. On the first example, we shade above. On the second one was below, and the third one's above. Let's look at the fourth example. So we have y is less than negative x minus 1 squared minus 1. Find our vertex. It's going to be 1, comma, negative 1. And it's going to be opening downwards since it has a minus sign in the front. And then go ahead and plot some points. So 2, 3, 4, 5, 6, 7, 8. Again, I'm counting to 8 because these are in increments of 1/2 instead of the usual 1. Okay, let's test the point 0, comma 0. So is 0 less than negative 0 minus 1 squared minus 1? Is 0 less than negative 1 squared minus 1? 0 is not less than negative 2. So it's false. Shade opposite side. So this is going to be below. When should you not use 0, comma 0 as a test point? Notice on all 4 examples we use 0, comma 0. It's easy to work with. However, there's one instance where you should not use it. It's when 0, comma 0 lies on the curve. So for example, if you had a quadratic that looked like this, 0, comma 0 is on the curve. You can't use 0, comma 0 as a test point when this happens. when it's on the curve. It doesn't matter if the curve is solid or dashed. You still can't use it if it's on the curve. You'll have to choose another point. Just any point that's not on the curve. If one's not on the curve, that's another easy one to work with. Here are your steps to algebraically solve quadratic inequalities. First, you set the inequality equal to 0. The second step, factor it out if possible. Third step, set each factor equal to 0 to obtain critical numbers. The next step, place critical numbers on the number line. The next step, use interval testing. And then the last step, write solution using inequality notation. So let's do that on this first example. It's already equal to 0. So now we're going to factor this. So 3 times 1 is 3. At the bottom we have 4. Two numbers that add up to 4 and multiply to 3 would be 3 and 1. So your factors would be x plus 3 and x plus 1. And that's less than or equal to 0. We're going to find our critical numbers. So our critical numbers is -3 and -1. We're going to put those numbers on the number line. We're going to put closed points since the inequality has an equal sign underneath it. Of course, we order them from least to greatest as well. We're going to use interval testing. So we're going to test some number that's less than -3, a number that's in between -3 and -1, and a number greater than -1 into the original formula. So let's go ahead and do that. So let's just say we're going to use -4, -2, and 0. Those are going to be our test points. It could have been any numbers as long as they fit those criteria. Those just look like easy numbers to work with. So let's go ahead and test these points. So -4 squared plus 4 times -4 plus 3, is that less than or equal to 0? No, that's not right. So that's false. So we're going to leave that part blank. Let's do the next one. -2 squared plus 4 parentheses -2 plus 3, is that less than or equal to 0? So that's a -4 plus 3. That is less than 0. So that works. So we're going to shade in this area. And let's try 0. 0 squared plus 4 times 0 plus 3, is that less than or equal to 0? 3 is not less than or equal to 0, so that's false, so we're going to leave it blank. So our answer is going to be -3 is less than or equal to x is less than or equal to -1. And if you want to write it in interval notation, it'd look like this. Let's look at the next one. So we have 5x squared plus 10 is greater than or equal to 27x. It's not equal to 0 yet, so let's do that. Subtract 27x from each side. And then we have 5x squared minus 27x plus 10 is greater than or equal to 0. Alright, let's factor this. 5 times 10 is 50. And then we have -27. Two numbers that multiply to give you 50 and they add to give you -27 would be 25 and 2, but they need to both be negative. Now, a is not 1 here, so we're also going to have to divide these by a. So our factors would be x minus 5 and x minus 2/5. I got minus 5 because negative 25 divided by 5 is negative 5. Okay, from here, let's find our two critical values. And then we get 5 and 2/5. Write these in order from least to greatest, and then now we're going to do some test points. So let's do 0 here. Let's do 1, and let's do 10. Okay, so let's test out 0 first, using this formula right here. Okay, 5 times 0 squared minus 27 times 0 plus 10. Is that greater than or equal to 0? Is 0 plus 10 greater than or equal to 0? Yes, that works. So we're going to shade this side in. Let's do 1. 5 times 1 squared minus 27 times 1 plus 10. Is that greater than or equal to 0? So we have negative 22 plus 10. That is not greater than or equal to 0, so we're going to leave that part blank. Okay, now let's plug in 10. 5 times 10 squared minus 27 times 10 plus 10. Is that greater than or equal to 0? So we have 500 minus 270 plus 10. Is that greater than or equal to 0? Well, 500 is bigger than 270. If you add something to a positive number, it's still going to be positive, so that works. Let's shade that in. So here's your answer. You're going to have x is less than 2/5 or x is greater than 5. If we wrote that in interval notation, we'd have negative infinity, comma, 2/5 union 5, comma, infinity. Okay, let's do this next one. 9x squared plus 6x plus 1 is less than or equal to 0. Okay, it's already in the equals 0 form, so let's factor it. 9 times 1 is 9, and we have 6. 3 times 3 is 9, 3 plus 3 is 6, so that would work. A is not 1 here, so we have to show that we're going to divide by A. So 3/9 reduces to 1/3, and it's just the same thing twice. So we have x plus 1/3 and x plus 1/3 is less than or equal to 0. So your only critical value is negative 1/3. So let's test a point on the left and right sides of this. Let's do 0 and negative 1. So let's plug in negative 1. So is 9 minus 6 plus 1 less than or equal to 0? 3 plus 1 is not less than or equal to 0, so we're going to leave that side not shaded. Okay, let's try 0. 9 times 0 squared plus 6 times 0 plus 1. Is that less than or equal to 0? 0 plus 1 is still not less than or equal to 0, so we also don't shade that in. Nothing is shaded except for the point that we found, since it has a line under it. So our answer we can only write in set notation. Now, if there was no line under this, there would be no solution. And if the sign was flipped, it would be all real numbers. Let's look at this next one. Ax squared plus ax plus 2 is greater than 0. These are all even numbers, so we could divide everything by 2 to make everything easier to factor. So now we can factor 4 times 1 is 4, or b is 4. 2 times 2 is 4, 2 plus 2 is 4. A is not 1, so we're going to have to show that we divide by a, which is 4 in this case. So we have x plus 1/2 squared is greater than 0. So our critical point here is going to be negative 1/2. Let's check two numbers. Let's do 0 and negative 1, just like before. So let's check negative 1. So negative 1, 4 times negative 1 plus 4 times negative 1 plus 1, is that greater than 0? Is 4 minus 4 plus 1 greater than 0? Yes. So we're going to shade that side. Okay, now let's do 0. And that's a yes. So it's all real numbers except for negative 1/2. So we have x is less than negative 1/2, or x is greater than negative 1/2. You might also see the notation, all real numbers except x cannot equal negative 1/2. Alright, let's do the next one. 4x squared is less than 9. Let's divide by 4 and get the square root. So we have x is less than 3 over 2. And you have plus or minus since you took the square root of it. So we have 2 points to consider, negative 3/2 and positive 3/2. So let's check the numbers 0, 2, and negative 2. So let's check negative 2 first. So is 4 times 4 less than 9? No. Leave that part blank. Okay, let's try 0. Is 0 less than 9? Yes, that's true. So we're going to shade that middle part. And then let's try 2. 4 times 4 is 16. 16 is not less than 9, so we're going to not shade that in. So our answer is negative 3/2 is less than x is less than 3/2, also known as parentheses negative 3/2, comma 3/2. Okay, let's do the next one. X squared minus 16x plus 64 is greater than or equal to 0. Let's factor this. So we have 64 and negative 16. So we're going to do negative 8 and negative 8. A is 1, so we don't have to show that there would be a divide by a. So we have x minus 8 squared is greater than or equal to 0. So we have one critical point to test, and it's 8. So let's come up with some test points. Let's do 0 and 10. So let's try 0 first. $64 is greater than or equal to 0, so we'll shade this side in. Now let's try 10. So we have 100 minus 160 plus 64. So it's negative 60 plus 64. that is greater than or equal to 0, so we also shade that in. So our answer is all real numbers. Let's look at the last one. X squared minus 12x plus 36 is less than 0. Let's factor this. So we have 36 at the top, negative 12 at the bottom, and negative 6 and negative 6. So our critical point to test is 6. So let's come up with 2 test points. Let's do 0 and 10. Okay, let's try 0. So is 0 plus 36 less than 0? Is false. So don't shade it in. And let's try 10. So we have 100 minus 120 plus 36. Is that less than 0? $16 is not less than 0, so we don't shade that in neither. So we put no solution. It's no solution because even the critical point 6 is not included because there's no line under this.